Welcome to Rerouting Hatfield, our vision of an urban strategy where waste to resource takes center stage. We're the Biomass Waste Group, changemakers digging into the potential of biomass waste to redesign systems for a thriving future. Our group members are
Annemie Deploy,
Hanke de Blanche,
Kelly van der Vever,
and Margot Pierre. In 2020, the Department of Environment, Forestry and Fisheries reported that half of the 55 million tonnes of general waste was organic. Green Cape highlights that removing organics from the waste stream not only improves quality and demand, but also increases the value and volume of dry recyclables. Nearly half of Tshwane's waste is organic. Currently, only 4 of 12 metro landfill sites have capacity for dumping. Sorting organic waste at the source is crucial to easing that burden. Biomass is defined as the total amount of living things in a particular area. In its broadest sense, biomass waste refers to any organic material apart from the primary material for which a plant was grown for. Almost all of these so-called wastes have some kind of value today. Biomass waste falls into two types. Green waste like grass, food scraps and manure, which is nitrogen-rich and great for composting, while brown waste like leaves, wood and paper is carbon-rich and ideal for energy generation. Using biomass for energy reduces fossil fuel reliance, cuts waste and lowers emissions. We now move to Hatfield as our study area. Through desktop research, analysis, and rough calculations, we mapped out how biomass waste is generated in our study area. The map tells a clear story. Educational sites are lush with greenery, residential zones have a solid number of trees per block, but corporate and commercial areas are strikingly sparse. One thing that jumps out across the board is just how little intentional public green space there is. In Hatfield, 715 households generate roughly 13,000 cubic meters of garden waste yearly, about 18.4 cubic meters per home, plus 26 tons of food waste, according to CSIR data. Most of this ends up in municipal waste sites, though we'd hope some are composting. Local schools we spoke to aren't separating or composting food waste, citing space issues. Restaurants aren't much better. Over half of the 21 we contacted don't separate waste, sending nutrients to landfills, though one uses the Bokashi system. These spots churn out 2,200 coffees daily, producing over 2 cubic meters of coffee grounds monthly, nearly all dumped, except for one saving grounds for pickup. Limited space, knowledge, and training keep landfill disposal as the go-to, overshadowing smarter waste options. The University of Pretoria shines with its campuses, landscapes, sports fields, and experimental farm that produces various types of garden and food waste. 15,000 cubic meters of garden waste was composted in 2024 on Hillcrest campus.
Zero waste preserves resources by responsibly producing, using, reusing, and recovering materials, avoiding harm to the environment or human health. It could cut a fifth of global emissions down in cities if managed properly. By seeing waste like biomass as a resource, not a burden, we can shift from a linear to a circular system where nothing is wasted.
The following map shows how the majority of biomass waste generated in Hatfield goes to landfill, with a limited amount going for composting at UP.
Upon examining the biomass waste system, it becomes apparent that it relies heavily on the landfills and garden waste dump sites. Tree felling companies dispose of their waste at these dump sites, with only occasional large logs being diverted to the UP composting facility. Food waste from residential and commercial sources, including restaurants, is sent to landfills, with minimal separation and recycling. Meanwhile, cow manure from the experimental farm is transported to the UP composting site, but only a limited portion is utilized. This linear system of biomass waste management neglects the inherent value of these resources, instead treating them as waste destined for landfills.
Through stakeholder engagement, we realized the land in Hatfield isn't just a setting, it's the physical and ecological foundation of our urban strategy, deeply tied to biomass waste. It's our key stakeholder, burdened by waste yet brimming with renewal potential. Inspired by discards theory, we view waste as a resource, not an end. By seeing the land as active, we transform it from a dump into a regeneration hub, so central to our sustainability goals. The University of Pretoria and Hatfield CID, our key institutional stakeholders, drive Hatfield's urban and ecological future. UP, a major landowner, produces significant biomass waste, while the CID, funded largely by UP, manages public spaces impacted by it. Local schools add to this with organic waste from their grounds. Together, UP and the CID spearhead rethinking waste for broader impact. Local businesses in Hatfield, including restaurants and coffee shops, produce significant organic waste daily. These businesses are key players in both generating and benefiting from sustainable biomass waste, making them vital to shaping Hatfield's economic and environmental future. Our group's focus on biomass waste hinges on understanding who's behind it. Meet our 5 user archetypes. The local resident. Imagine a young family tossing out their food scraps from meals and garden trimmings, generating daily organic waste. The commuter grabs coffee and snacks at the train station, adding to food waste piles. The university student, living off campus meals and study snacks, fuels UP's biomass output. The scholar, a schoolchild, leaves their lunch leftovers that stack up on the school grounds. And the professional, tied to bustling eateries, drives waste from Hatfield's business core. These users shape our waste landscape, making them vital to our zero waste and end goal strategy. Our analysis shows Hatfield's city grid favours vehicles and lacks building permeability, unlike Cape Town's smaller pedestrian-friendly grids, or Barcelona, our precedent's superblocks, which prioritise walkable, human-centric spaces with better pathways and courtyards.
Our studies of Hatfield streets revealed, as indicated on this map, where heavy traffic, narrow sidewalks, and limited to no buffer zones overlap.
Through desktop studies, we mapped out student and residential housing. We saw that there is an infiltration of student accommodation into the historically residential area.
Our current observations in Hatfield show a lack of shading, monofunctional programs, fences, limited planting palettes, mundane public spaces, underutilized spaces, and litter.
Our research highlights key issues in Hatfield. Biomass waste is seen as a problem, not a resource. Public spaces lack vibrancy and third places for connection. Mobility is hindered by the street grid and railway. Green spaces are monocultural, and there's a divide between students and permanent residents. Addressing these can make Hatfield more connected and livable.
Imagine a world buried in waste. We push it aside, but if we keep dumping irresponsibly the way we have been, we'll soon live, breathe, and build on it.
The challenge state will reassess Hatfield's existing systems to help us reach our goal. C40 unites mayors fighting climate change through circularity and waste management. Standouts include Stockholm with biochar carbon sinks, Pex with a massive biomass plant for green heating, Maribor's job-creating waste strategy, Phoenix's focus on diversion and education, Copenhagen's source separation success, and Gothenburg's push for public involvement. These cities prove waste as a chance to build smarter, sustainable systems. While exploring precedents for urban public green spaces, we stumbled across the idea of the pocket park to take underused spots in cities where outdoor space is sparse and turn them into small functional urban parks. Melissa Curie laid out a design framework for these pocket parks, and we see it in action in places like Glassfields Park in Bristol, designed by BD Landscape Architects. Another great example is the MLK Gateway in Portland. This one transforms a vacant plot sandwiched between busy roads, highly visible yet cut off from the urban fabric, into something useful and inviting. This is relevant to Hatfield, especially at our identified transport node on Jan Schauber Street, where we have similar disconnected overlooked spaces. The Portland design creates a clear entry point, signaling you've arrived, while also carving out a gathering spot that brings people together. The Stockholm Biochar project converts municipal garden waste into biochar, which is then used to enrich community plantings. This process, called pyrolysis, has been used for centuries to improve soil while also producing energy, syngas, and bio-oil. Unlike decomposition or composting, biochar sequesters 50% of carbon, making it a powerful climate solution. In the project, biochar was used as the main component in the structural soil of these urban tree planters. Biochar has many benefits for urban planting, such as supporting soil microbiome, mitigating soil compaction, stormwater filtration, and increasing soil porosity. Mochikabedi, a community-driven garden in Hatfield, transformed a former landfill into a productive urban space, supporting food production and therapy programs. It showcases the value of integrating city infrastructure, but could improve with a stronger connection to the nearby railway station. Limited programs and low public visibility also restrict its broader community impact. From the key challenges we identified, we've developed 5 guiding principles to shape our strategies. First, we need to rethink biomass waste, not as something to dispose of, but as something valuable that is waiting to be reutilized. Second, by boosting the permeability of the area, we can tackle the barriers holding back user mobility. Third, it's time to move away from single-use monocultural green spaces and towards diverse regional urban ecology systems that thrive. From the key challenges we identified, Fourth, we can transform dull, overlooked spaces into vibrant, interactive third-place landscapes that people can actually spend time in. Fourth, we can and finally, we must put the Hatfield community front and center. Integrating and engaging them is an absolute priority for this to succeed.
Welcome to Hatfield. Once tied to its student pulse, the city now opens its arms wider, its streets reshaping into finer grid that eases barriers and nudges neighbors towards shared corners, paths prioritizing rhythm of footsteps. Here and there, community gardens emerge. In some pockets, biochar kilns hum modestly, their output enriching the soil and hinting at waste's worth. Green transport hubs offer a pause amid the daily grind. Hatfield's renewal is no dreamscape, but a grounded shift, a city rerouting for its people, where land and community find adequate renewal side by side. Our Hatfield design includes the following: railway and transport nodes, greenway and the reduction of motorized transport, biochar production at human scale, more pathways and smaller blocks, community interaction and spaces beyond the student population, biomass discard to energy, biomass discard to compost, and engineering hub. Through moving student housing to a Hillcrest campus village, we hope to create a balance between the fleeting student population and the permanent residents in Hatfield. Mixed-use buildings activates the streetscape and encourages interaction between communities.
This is a vision of what our local train stations could be. It doesn't just serve commuters, but enriches the urban ecology with indigenous plants, breathing life into the regional ecosystem. Here is a place where mundane transforms into a vibrant third space, planters, seating, and shade, turning it into a lively hub. Here, isolated commuters become an engaged community, connected by a dynamic gathering spot filled with greenery. Biomass waste is no longer discarded but reborn as resources in planter box benches. This is more than a concrete shell, it's a living, breathing part of Hatfield. Imagine a community space in Hatfield, a planting park that enhances urban ecology with a compost-fueled garden, where residents and land collaborate to transform the urban fabric. It's a vibrant, neutral third space, alive with interaction, turning local organic waste into shared resource that unites residents and students. Mobility hurdles fade as this pocket park, powered by compost, links Hatfield blocks with permeable green spaces. Here, biomass waste isn't just collected, it's showcased as a usable resource, educating everyone on its potential. This isn't just a park, it's a living, breathing part of our community.
In a circular biomass discard system, implemented strategies cultivate valuable resources. By adding more vegetation with increased buffer zones, we create more biomass discard. Biochar gets produced with biochar kilns at human scale and energy is ultimately generated. Soil is rejuvenated by biochar. This discard system of biomass excludes the need for anything to be wasted at landfill.
Issues surrounding this area include a lack of pedestrian permeability through large blocks and crossing over the very busy Jan Shorba. As the area develops, there will be more pedestrian movement that needs to be catered to. By developing a greenway along the entirety of Prospect Street, this project links two campuses, forming a vibrant route. The greenway introduces an extra meter of green space along the width of the kilometer stretch of Prospect Street. Along with doubling the amount of biomass, the greenway alone can introduce 117 tons of biochar potential while sequestering 234 tons of CO2. The Prospect Street Greenway enhances mobility with a protected NMT route, transforming the area into a lively linear park and green corridor. Further promoting mobility, future development should increase block permeability through corridors, courtyards, and public green spaces. At the building level, medium to high density should be promoted, incorporating mixed-use typologies with active ground floors. Semi-public green spaces should be integrated, while vertical greening enhances and supplements existing on-site greenery.
Increased density supports a mixed-use environment with an active ground floor, fostering a lively and connected urban experience. The greenway increases permeability by promoting urban mobility while also creating an intentionally designed third place that engages with the community. Biomass waste is collected in dedicated at-source sorting stations, helping to valorize waste in the public eye. Diverse indigenous planting is dotted along the greenway and as well as in generous sidewalk buffer zones.
Transport nodes like bus stops and train stations are often dull and overlooked. These invisible third spaces have the potential to become vibrant hubs that enhance urban connectivity and liveliness through thoughtful design. From our site observations at the Rissik Street train station, we've seen informal trading and people lingering around these spots, but these activities could be better supported. Imagine waiting for a bus or train not as a dull, tedious chore, but as a chance to enjoy your surroundings. Our vision is to weave these access points into the city's fabric, blurring the lines between the station and the streets through shared spaces and activities. This could transform Hatfield into a destination people actually want to experience and not just pass through. If these changes are implemented, transport nodes can account for 3,210 tonnes of additional biochar potential and sequester 6,420 tonnes of CO2 just from the green train line. The Rissik Street train station corridor is reimagined as a vibrant, active node with green railway tracks and train spotting opportunities. Informal food markets are facilitated to enhance activity while promoting food waste collection and visibility. Public and private parks are integrated, making Mojagabedi more open and engaging with retail stores. Its urban farming connects directly to local food vendors, creating a sustainable community-driven ecosystem. At Rissik Station, we can boost accessibility with wide covered sidewalks and waiting areas, improving the pedestrian and transit experience. The drop-off zone could become a third space with planters, seating, and shade, turning it into a commuter hub that supports informal traders with smarter on-site waste collection. Indigenous planting along sidewalks and waiting areas enhances ecology and appeal, shifting isolated commuters into an engaged community around a vibrant station. Across the station, an underused green space could become a vibrant pocket park, benefiting commuters, students, and residents. It's a chance to upgrade our railway greenway, turning the grassy field into a hub for activities alongside informal traders. Social spaces will blend with shaded seating, enhanced by indigenous plants that draw people in. Community composting and biochar plants could recycle biomass discard on site, creating an intentional design that engages the community and improves the urban environment.
Monofunctional public space with limited planting types creates underutilized third places. By reprogramming parks and other public green spaces and third places, the valorization of biomass discard becomes an integrated part of communities and reinvigorates third places to become well-used public infrastructure. Belgrave Square Park serves as the archetype example for our park strategy. By doubling the amount of planting, 9,135 tons of biochar potential can be achieved while sequestering 36,540 tons of carbon. Biochar kilns enable pyrolysis, allowing the community to collect biochar for personal use. Ancillary programming activates public spaces, transforming parks into vibrant city nodes. Boundary expression enhances interaction while providing seating. Indigenous landscapes are enriched with biochar to promote plant health and create a distinct urban African aesthetic. Biochar kilns function as drop-off points for garden waste within the community and become integrated into community life and leisure spaces. As the biochar project scales, biochar can be used in the construction of the kilns as a bio-based material. All in all, with the increase of biomass and the introduction of biochar, the valorization of biomass discard can sequester 43,000 tons of CO2, which is 4 times the current underutilized biomass potential. Turning biomass discard into biochar cuts emissions, enriches soil, and builds resilient urban spaces, rerouting Hatfield's future in regeneration.